way, my microphone is still working. Check. All right, let's do this thing. Step 1. If you do not have a leading coefficient of 1, if a is anything other than 1, we have to factor that a away from the x terms. Step 2, we have to make a perfect square. That's what this is, a perfect square binomial, or a square of binomials that makes the trinomial. But we have to take the middle term, cut it in half, and square it. And I'll show you, I'll model that for you in just a second. But that's what we're going to put into our blank. And we're going to need to add that either, what you add to one side, you add to the other. Either, to keep everything balanced, add to both sides, or, I don't know where my or went. You guys write a little or right here? You don't have to do both of those things. It's one or the other. Either add it to both sides. So what you add to one side, you add to the other. Still balanced. Or, from one side, you add it and you subtract it. You add it in one place, you subtract it. I'm still balanced. So either you add to both sides, balanced, or you add and subtract in your balance. Once you factor and simplify into the form, the standard form that we talked about, you should be able to see your vertex. You should be able to pull out what h is and pull out what k is just by looking at the form up above. But once again, if you do need to check, if you do want to check, you can check with the formula negative b over 2a for h and then plug it in and simplify for k. Alright, let's go ahead. Let me get an example up on the board. I think it's an easy one. I think the leading coefficient is 1. Yes. I think the leading coefficient is 1. So let's go ahead and play with this one. Now first of all, because some of you are going to get a little bit confused. Can I factor this trinomial? What do you guys think? Can I factor it?
Yes, you can.
Yeah. Do you guys see the factors? Like, this was one of those easy ones. 1's in front. I know it's going to be an x and an x to make 1x squared.
X minus 3.
4 and 3. And they're both going to be subtraction, right? Negative 3x minus 4x is negative 7x. They add to be negative 7, and they multiply to be positive 12. Could you have done the x off to the side, multiplied 1 by 12, and see what factors of 12 add to be negative 7? Yes. But in these ones, the reason why we skip straight to the answer is if you did do the grouping, I'm going to erase this in a second, so you might just want to watch. If we did do grouping, what always ends up happening is you end up, as long as there's a 1 in front, you end up with the product of the two factors with the two numbers that you found. It's always going to be that way. Grouping always works, but you guys pretty early on learned that most of your minds could mental math it and jump here if you just thought about the factors of 12 that add to be 7. What makes this type of factoring harder? When there's a 2 here, when there's a 4 here, when there's a 3 here. That's what makes it harder, right? Anyway, we factored it, but my question to you is this standard form? No. Is this y equals a times a binomial squared? Okay.
No.
They're not squared, they're two different ones, right? So factoring is good and all. It helps me find zeros and all, but what am I supposed to be doing? I don't have it. So what do? Alright, let me walk you through the steps to complete the square. Do I need to worry about factoring out a? No, he's 1. So I go ahead and say, alright, I need to keep the x squared term, I need to keep the x term, but the 12 didn't cut it. He's important, I can't get rid of him. I can't just exterminate him from the problem. But he only got me here, and this is not a perfect square. So I have to remove the 12 and say, no, sorry, buddy. You're still important, I'm still going to keep you, but you're not helpful for this task. So now I have a blank, and I leave this on purpose so that I don't forget what I'm doing. And technically, here are my two options. I could either subtract on the same side. That way what I add in, I'm going to subtract somewhere else to keep everything balanced. Or, here's the either or from the page before. or I add it on the other side. This time I'm going to add it on the other side. That's maybe how you did it in Algebra 1. That's how I taught my Algebra 1 kiddos back in the day. Add it to both sides. And here's what I showed you yesterday. Y equals, what are we trying to get? We know that the A is 1, because it was 1 from the beginning. So that's no big deal. But we're trying to get x minus somebody squared, right guys?
Right.
And I have this plus 12. And I have this 1. What did I say yesterday? Can you guys help as to what's always going to go in this pot? Half of the middle. So first of all, I keep the minus because I keep the signs the same. So whatever that middle sign is, that's the sign I have below. But then what do I do with the 7 as I come down? I cut it in half. Sure, you could do 3.5, but remember what I said yesterday? You have to square it. Can you square 3.5 in your head? Most of you are like, no. Okay, then don't use decimals. Can you square 7 halves in your head? Maybe not, but you should be able to. Because if you think 7 halves times 7 halves, don't you know 7 squared? Don't you know 2 squared? So all you need to know for fractions is how to square the top and the bottom. So in complete the square, as you're coming down to your form, you cut the middle term in half, keeping the middle sign. And how do you come back up? You square. If that's too much math, you can use words instead if that helps. So as we come down, think about cutting in half. And as we come back up, think about squaring. Now hold on. I'm almost good to simplify and be done. What have I not filled in yet? And I have to fill that in, because in math you can't just randomly add something to one side and say, oh yeah, everything's still balanced. So what I add in one side, I have to add to the other. Now, pause. I actually don't want to rewrite it on this side, because who am I supposed to get by itself? Yeah. So what am I going to do with this anyway? So don't you have to end up subtracting it anyway?
Yes.
Which is why I just add and subtract on the same side. Yesterday I added here and subtracted here because you're going to have to do that eventually anyway. But either way you do it, whether it makes more sense to you to add it on both sides, or whether it makes more sense to you to add and subtract on the same side, you're going to have to do the same, you'll get the same final result. Now hold on, we're so close. I have y equals 1, x minus 7 halves squared plus, I need to get this to be 1k, one constant, so what do I do? I could get a mixed number and say that's 12 and a fourth. 12 minus 12 and a fourth is negative a 4. 4. I could get a common denominator and multiply this guy by what? 4 over 4, careful. So now I have 48 fourths minus 49 fourths would be? Instead of plus and negative, I'll put a big old minus. Question, do I have standard form?
Yes.
However, is there another way? I don't want to lie to you guys. I don't want to pretend as though there's not. Is there another way that you could have gotten that answer? How? Take a second, look at the steps that you wrote a second ago. You guys were writing the steps at the very beginning of class. We can complete the square, and that's what we did, steps 1, 2, and 3. But what did I write off to the side that we can check with?
Negative 8 over 2a.
Okay. You could have technically gotten here as well by saying, and some of you will like this better, I'm going to try to show you why I don't think it's a wise choice for most of you. But you could have also gotten to y equals a times x minus h squared plus k by doing the following. Who's a for this one? 1. Who's b? Negative 7. Careful. And c is 12. So I can plug in a. Okay, how do I get h? What's the formula?
Yes.
Who's B again?
-7.
Okay, so then -7 is going to be a,
+11.
and then who's A?
1.
Couldn't we have gotten 7/2 just by plugging into this one formula?
Yes.
Oh man, I'm so close to being done. Psh, I'm never going to do that. That's silly. Wait, pause. What do you got to do? You got to find K. How do we find K? You can look in your notes if you want. Right underneath H equals -B/2A, I drew a little line and said, how do we find K?
K equals half of -B/2A.
So to find K, I have to plug 7/2 into the function. Who's my function? So fractions don't scare you? Sure, plug in 7/2. Square it, -7 times 7/2. Oops, but actually write halves. Not 12. Plus 12. Don't want to lie to you. You can do that. You can use -B/2A, get 7/2, plug it in. Then you can go to the function, you can plug in 7/2 squared. Just a few of you are going to make mistakes here. And I'm hoping the math is a little bit more spread out up here so that you wouldn't make as many mistakes if you got good at it. But down here, don't you also get 7/2 times 7/2 is 49/4? Wait, what's going on with the second term? What do I do with 7 times 7/2? Yeah, but careful, isn't it 7/1? So not totally squaring. On top I do have 49, but on bottom I only have a half. And then what can we do with the 12 like we did up above to help us out? Remember what we made 12? Yeah, 48/4, right? So I could multiply 12 times 48/4. Sorry, times 4/4. And I can almost put all this together, except what am I going to do with that middle guy? What do I still have to do? Yeah, I still have to get a common denominator. So I can move this guy off to the side. I'll have to struggle. I have to get them all to match before I can put them together, unless you're really good at mental math with fractions, and some of you are. Now I'm going to end up with 49/4 minus 98/4 plus 48/4, and some of you are like, yeah, I don't like this. But it works, I just want to prove that to you. 49 minus 98 ends up being a -49/4 plus 48/4 is -1/4. Did we finally get our calculator? So we can find H real fast. K is going to take some mental math with fractions. But once we have K, now can we go ahead and say, hey, without completing the square, I was able to get x minus h squared plus a negative, which is just like minus. Both ways work. Which way would you prefer? It's up to you. I think the math is easier in the top, you just have to learn the process. The bottom, the math is kind of hard if you don't like fractions. If you do like fractions, it's not bad, you just have to work with the fractions and simplify. But if you think the top is easier, less math to do, more process, do you like that? Well, let's get good at it. If you don't like that, then you're going to have to do this and be very careful not to make mistakes. Okay? Does that make sense? So if you're finding the vertex, the H and the K, and or if you're getting into standard form, I think complete the square is a good way to go. Now, pause. I'm going to do this example to complete the square way. But if some of you guys are like, no, I think I can do the -B/2A, and I think it's better for me, why don't you go ahead and start? Why don't you go ahead and start? If you think you want to use the -B/2A, right now I'm just going to say, okay, go, just start it right now, the -B/2A, if that's what you want to do. I'm going to complete the square, and then we'll compare and see if we match up. Is anybody willing to be like, you know what, I like to plug in one? Oh, no one wants to try to plug in one?
A lot less
Okay. Well, fractions are scary, but every now and then there's someone who's like, I'm not scared of fractions, I got this, and that's fine, because it might be easier for them, but let's do complete the square one. So if we're completing the square, is someone tracking enough that they can tell me the first thing I should do? This one's harder. It's our first thing. Factor out what? Now, wait, 3 doesn't come away from 7. Is that bad? No, because what are we doing? Isn't the 7 not good anyway? Aren't we going to put them off to the side anyway? Okay, so let's go ahead and do the following. Ready? The 3 is going to come out. The 7 is going to not be ostracized, but he's definitely being separated, right? He's being segregated over there. 7 doesn't cut it. You try to factor it, long story short, the 7 doesn't cut it. This one doesn't even factor nicely. It'd be nasty decimals with the quadratic formula. I'm pulling the 3 out. You guys are totally right. So what's going to be left inside when I pull the 3 away from each of the x terms? Now I need to put my blank, because if you don't put the blank, you get all lost. I get lost too. Now question, do you guys want to add to both sides and have to subtract this one later, or you just want to add and subtract now? Okay, so we'll just say it's a minus. Is that okay?
Yeah.
We're just going to subtract. Now here's one more thing, just to try to, I see so many common mistakes in this process. Can I show you something right now? Whatever I put in this blank, does it make sense I'm going to have to add in here and then subtract 3 times that over here? Okay, pause. Why am I putting it 3 times? Just to show you what I'm about to do. What's going on to this guy outside since you pulled out the 3? If I add a 2 in here, I'm not really adding 2. What am I adding? 6. If I put a 4 in here, I'm not really adding 4. I'm adding 12. So whatever I put here, I have to offset with 3 times or triple that number. Does that make more sense? So whatever I put here, you've got to look in front. The other one, if you're wondering, well, we haven't done that before. I kind of talked about it, but this one, did I have to worry about multiplying it by anything?
No.
It just got to stay the same because that's what was going on. But in this one, since I have the 3 in front, I have to say 3 times. I just wanted to show you guys that now before we started doing our process. Okay. What's vertex or standard form? Last year it was called vertex. This year it's called standard. Good. Y equals A. I have the 3. X minus something squared plus. Okay. First of all, is this going to stay a minus? Nope, because I steal. It's all about the middle term. I steal the sign, so it's going to be a plus instead. And then what number is going to go in? What do I do with the 6? I cut them in half. Does that make sense?
Yeah.
I'm writing half. And what do I do as I come back up? I square. So I cut in half as I come down, and I square as I come back up. So what's going in my blank? Pause. Does that make sense, Michael?
So then you 3x.
Just a second. Here's the reason why. Remember when I factor a trinomial, I usually have some sort of x plus a. I don't need to put an x in this spot. Now this one I'm squaring, so it's going to be the same thing squared, but the same process applies. I have an x and I have a constant. That's also a good thing for those of you guys that are like, oh, she said steal the middle, but I don't mean the middle term, I mean the middle coefficient. I don't mean the middle term, I mean the middle coefficient. Now pause, what do I need to put here? Which is really, now, do you have to write? No, you could have just written 27. Does that make sense? You could write 3 times 9, or you could write 27, but either way, when I put a 9 there, in essence what I'm doing is I'm adding 27. So if I add 27, I can't subtract 9. That's not going to keep me balanced. If I add 27, I have to subtract 27. What is 7 minus 27? Oh, guys, we're done. Because what's h? And what's k? Done, done, done. We're done. A times x minus h, well actually h would be a negative 3. I'm not sure if you guys said that. Now it just said get it into the form, which it is, but if they wanted the vertex, it'd be -3. So if they wanted the vertex, let me show you one more thing. At the very beginning, maybe you don't remember me saying this, but I was like, if we were to factor right now, 7's not going to cut it. I said something like that. And then I was like, oh wait, 7 doesn't even work. Because this doesn't even have nice factors or nice zeros. How did I know that? If we were to factor this the old-fashioned way, looking for zeros, 7 times 3 would be 21, right guys?
Yes.
Are there any factors of 21 that adds to be 18?
No. No, man.
1 and 21, 3 and 7, no. There are no nice factors, meaning there's no nice way to factor to find zeros, meaning, I would have had to use quadratic formula. X equals negative e plus m on the square root. Wait, if you have vertex form, I said it would be helpful for vertices, but also for zeros, but why? If I set this equal to 0, you have to use the quadratic formula. If I set this equal to 0, can we do that real quick? It actually happens in homework a couple times. What happens if we set this equal to 0? Do we need the quadratic formula? No. What can we do instead? Solve. And the first thing I would do is, well, let's add 20. He's already factored. I mean, not like the way we're used to factoring, but he's already in his form. Add the 20. What happens when we add the 20? We have 3 times x plus 3 squared. What do I do now? Careful. Yeah. PEMDAS backwards. Undo the addition, subtraction, undo the multiplication, division, and undo the exponents. PEMDAS backwards. Divide by 3. Ugh, 20/3 is gross. No, that's okay. We knew it was going to be gross. No nice factors. Okay. Now what do we do? How do we get rid of a squared? We have 20/3. Yeah. Now pause. You might not remember much of the quadratic formula, but you should remember there's a plus and a minus. How are we going to get a plus or minus here? If you square root, you put in a plus or minus. If you square root, you put in a plus or minus. And last but not least, subtract the 3. If you want to be super snazzy, technically this is root 20 over root 3. We'll have to rationalize in a second. And then put a little -3 in front just to make it a little bit prettier. Usually square roots go at the end of expressions. And we end up with x is equal to, let's see if you guys can make this jump. -3 plus or minus . Is there something we can do to square root of 20?
Oh, we can start with
Oh, 4 and 5 goes into 20, right?
Yeah.
What's special about 4? It has a square root. We could simplify that radical to be 2 root 5, right? Square root of 4. In case you're wondering, square root of 20 is the square root of 4 times the square root of 5, which is 2 root 5. Review from, I don't know, simplifying radicals, algebra 1, algebra 2. So I simplified the root 20. And what do we do when we have radicals in the denominator? Do you remember? Rationalize, multiply root 3 over root 3. So we end up with 2 root 15 over 3. Now, I want to keep it up on the board. If someone's watching the video, I'm really sorry. I'm going over to the whiteboard just for a little bit. There's a smiley face. Go team. I'm going to put that up there. I think it's a calculator. Someone bored during zero period. We would have had to solve this. X equals negative b plus 2 minus square root a squared minus 4ac. Okay. These are nasty zeros. They're not nice ones. We would have had to use quadratic formula if we hadn't gotten it into vertex form. Help me out, kiddos. You can see it better than I can. Who's B?
18 and 18.
Is it negative? Oh, it's positive. So Negative 18 plus or minus square root 18 squared minus 4. Who's A?
3.
Who's C?
7.
All those are positive?
Okay.
All over 2A. What would you have had to do? Remember, what if you didn't have a calculator? 64, that's a 4, and a 6, that's 144. We have 8 and we have 1. And then we add down, we have 4, we have 2, we have 1, we have 3. You should be able to do that. Doesn't mean you like it. You should be able to multiply.
Did you do that?
2 column multiplication. And I multiplied. 8 times 8 is 64, carry the 6. Keep the 4. 8 and 1 is 8 plus 6 is 14. Take a 0 to carry the place. 1 times 8, 1 times 1. Add. Now you can tutor little elementary kids. Okay, so come back. It's sad how much math we just get lazy at. And we forget how to do. But we have 324. So then you would have to go ahead and say negative 18 plus or minus the square root of 324. 4 times 3. Oh, it's 12 times 7. My 12 multiplication tables. 84, hopefully you guys got it. Do you see there's a lot of math going on in here? And I have negative 18 plus or minus the square root of 324 minus 84. You gotta be kidding. 324 minus 84. 4 minus 4 is 0. 2 minus 8 doesn't work. I have to carry the 1. Take away. 12 minus 8 is 240. All over 6. This does not look like that. Because it's not simplified. What goes into 240? That's a perfect square. 4 goes in 60 times. But guess what? We can go further than that. What goes into 60? 3 imperfect squares? Yeah, 3 and 20. Oh, hey, 20. There's another 4 in there somewhere. Ends up being 15. So I can say 240 square rooted is the square root of 4 times the square root of 4 times the square root of 5. Isn't that going to be 2 times 2 times root 5? Okay, so then I would say negative 18 plus 4 root 5 all over 6. Still not the same thing. Oh wait, simplify more?
Isn't the square root of 2 not
Oh, yeah, so it'd be 2 times. I didn't write the 1, did I? Thanks, guys. Man, there's so many numbers, I started losing them. Now what can I do?
3, 6.
Dividing by 6 over 1 is multiplying by 1 over 6. You might not like this, but it might help you understand why I'm about to do what I'm about to do. The 1/6, each piece needs to be divided by the 6. So the negative 18 gets divided by 6, which ends up equaling negative, which is negative
1.
negative 3. These C kids think they own everything. 4 over 6 is 2/3, right? Oh my goodness. What did you probably learn more in Algebra 1? That or that? Didn't you use quadratic formula? You had to memorize it, you had to chant it, you had to plug into it, but which one's harder to do? Look at that, look at all those huge numbers. We're lazy, we don't like to do 18 times 18 or 240 cut into factors. If we could just learn how to complete the square, we would basically never need to use the quadratic formula again. But if you don't get this down, well, you better have that really memorized and not make mistakes and be willing to do lots of multiplications and divisions.
So all that is just for one problem.
Well, technically this problem ended right here.
Then why did you do that?
Yeah. Because, do you remember? I know it's been a long time. I said, what if they wanted you to get the vertex, which some problems will ask? And what if they wanted you to get the zeros, which some problems will ask? So I went ahead and turned this one problem into a mega problem covering all the different applications that you could use this for. And what I was trying to say was, remember yesterday how I said some of you guys don't like complete the square, but I'm trying to show you that it's helpful. And I think what I wrote for complete the square back here was that it can be helpful for zeros, what we just did. Graphing vertices and zeros, which is what we're finding. And alternative to the quadratic formula, that's what I tried to show you. Does that kind of make sense? So I was trying to show you how it can help, and I was trying to show you how what you learned a long time ago in the quadratic formula, there might be a better way. And that was this one. So, pause. Let me see how many examples. Oh, that's just factoring practice. We've already done some practice on complete the square. Let me go ahead and save this one for workspace tomorrow. Sound good?
Yeah.
I'll save this one for workspace tomorrow. I want you guys to practice complete the square tonight. And to figure out which way you like finding zeros and vertices. Whether it's using the old school methods, or whether it's using the new complete the square. And then in workspace tomorrow, you get to choose how to solve this problem. Am I making you put it in standard form using complete the square? No. I'm just going to ask you to find the zeros and find the vertex. And some of you are like, wait a minute, this one factors nice. I don't even need the quadratic formula or complete the square. But you would need to find the vertex, which is messy. So tonight, you're going to try and figure out what's your preferred way of solving this. Tomorrow we'll practice. As I move that to the end of notes then, we're going to pause on that because we practiced it quite a bit this year. Let's go to talking about quadratic graphs for a little bit. Just for a little bit. The nice thing is the math calms down right now. It's more of a visual thing on this page. Let me freeze the screen and let you guys write down a few things. Let me go ahead and just save you a little bit of time because this is really light. It's hard to see. Don't stress about him or him. Instead, just put A is greater than 0 and A is less than 0. There we go. I think there are some things in homework that ask about, I think it's even in the terms at the beginning, when a vertex is a max or a min. This page will help on some of those terms. All right, is it frozen? Good. A couple years back, we hadn't really practiced factoring a lot. That's why I had all those factoring problems ready. This year we practiced it more, which is good. So if you have time today, we'll do a little more factoring practice, but otherwise, let's save it and bring it back. I see you guys are struggling with factors. So. The majority of you. If the majority of you aren't struggling, if some individuals are, no problem. Come on in. I can help with factoring. I just need you to give me a chance. The nice thing is now, neither calculus class is having any tests this week or beginning of next week, so it's pretty calm after school right now. Now's a good time to come in if it's something that you know that you're struggling with, whether it's factoring, whether it's, I don't know, what do you see today, radicals, whether it's new math, whether it's review math. Come on in, I'll grab your whiteboard and practice a few things. It's a lot easier for me to help you with your individual struggles with a whiteboard after school. Now's a good time. Okay, you guys are writing down stuff about graphs. We already know the graphs of quadratics are called what again? Oh, I thought I heard you. Yeah, parabolas, right?
Yeah.
I know. Well, I thought I heard someone say it, and I'm like, oh, maybe I didn't. Anyway, parabolas. In case you guys didn't know how to technically say it, or you forgot, you've heard it before. If the parabola is facing up, and that always happens when the leading coefficient is positive, we say it opens upward, which makes sense. It's opening upward. But another way of saying that is it's concave upward, or we can say concave up. I shorten that sometimes just because we use, or we talk about concavity in calculus fairly often. I can also use C.U. concave up. This one's opening downward. Hopefully we see that too. So I would call this one concave. Yeah, does that make sense? Concave down. Or I could put CD, C period, D period, concave down. So the concavity is talking about how it's open. If it's opening up, if it's opening down. And I have a silly way of remembering it, and I think a lot of you already remember this from last year or even Algebra 1. But if the leading coefficient is positive, the x-squared term is positive. If you're a positive person, hopefully you smile sometimes, right? Concave up. If you're a negative person, you're frowning at least part of the time, right? So it's a silly way of remembering it. But the leading coefficient, which is also known as the A, if it's positive, you're going concave up. If it's negative, you're going concave down. With concave up, you have a low point. And the vertex is the low point, which means when A is greater than 0, the graph is concave up, and the vertex is a minimum. The vertex is a minimum. So the vertex we know is HK. But if you have a concave up parabola, then the vertex is a minimum. And if you have a concave down, well, you have a high point, the highest point, so then the vertex is a maximum. So if you ever, for a parabola, if the question ever asks for the max or the min, it's just asking for the vertex. You can find it by looking at the vertex. We've talked about the axis of symmetry before. Remember, that's the line about which the parabola is symmetric. Because if the parabola gets moved, it's not symmetric about an axis. It's symmetric about its own axis. And we call that the axis of symmetry. And how do we say or how do we state that? Every vertical line is a tick mark on the x or goes through a tick mark on the x-axis. And so we say x equals, oh hey guys, do you see that the axis always goes through the vertex? Doesn't it always go through the vertex? Because the vertex is in the middle and the axis is the middle fold line? Okay, so what is the x going to equal? What's the x of the vertex? So the axis will always just be h, and if you need to find it quickly, you can use the formula. It's just the h, the k is the hard part. So the axis, just always steal the x of the vertex. They're going to share the same x value. I already said this one. How do you find maximums or minimums? Find, solve for the vertex. So the vertex is important if we're graphing. The vertex is important, well, I guess, if they ask for it. But the vertex is also important because if a quantity has a parabolic behavior, the vertex can be the max or the min. Which I'm grossly oversimplifying this because we're not quite at a level where it can make it super applicable. But if you're a business, don't you want to maximize profits and minimize costs?
Of course.
That's just a super basic example. But maximums and minimums are pretty stinking important things. So then, kiddos, what do you think the process would be? We have a few minutes. If you want, why don't you just drop your pencils? That's okay. We've done examples today. You can watch the video later. How about I just do it and you guys try to track along? Sound good? Okay. So, I need to find what stuff? Which means, what letters? What else do you need to find? Which is the same thing as? Oh, so I'm really just finding the vertex? Yeah. How am I going to do that? What do you guys want me to do? Negative b over 2a to plug in? Ooh, why did you say yes this time?
Because they're
Well, we can see though. Maybe people said yes because they figured out maybe it's easier sometimes. What's negative b over 2a for this problem?
over 2 over 4.
Oh. Negative 8 over 4 is negative 2. Is the h scary this time?
No.
So maybe the formula sometimes is easier. Maybe you should check it real fast. If it's a fraction, some of you are going to be like, I'm not going to touch that. Complete square of these, right? But this is not a fraction. So maybe if I plug in, it's not too bad. Now, some of you are still kind of scared about this, but hold on. It's a lot easier than a fraction. I'm just trying to show that just because you say you like one method better doesn't always mean it's the fastest. And I don't want you to get like blindsided and be like, oh, stink, I could have done it faster. What happens when we simplify? PEMDAS says square it. What's negative 2 squared? 4. 2 times 4 is
8.
And then I have 8 times negative 2.
Negative 2.
Can I give you a mental math trick? If you have two positives in a string of addition and subtraction, put them together. 8 and 7 is 15, minus 16 is.
I didn't get that.
Makes it a little bit faster. Some people like stress about that and then they get lost by that. Vertex, I have -2. Axis of symmetry. Just steal the just the H. Now, could completing the square have gone fast too? Yeah. And if you don't believe me, let's see if I can finish it by. Do I still have a minute? I do, right?
Yep.
What's the problem? 2x squared?
Plus 8x. Plus 7.
It's so cool.
How'd I do?
It's great.
Oh, thanks. I was just trying to find the vertex, so I was being slow. I was being imprecise. So guys, that took me 30 seconds. Now pause. I'm not saying it's going to take you the same amount of time,
Yeah.
but if you develop complete the square, the math facts are technically more basic, but the process takes time to get good at. Does that make sense? And why was this one so easy? There were no fractions. It was a nice pull out and solve. The fraction ones will take you longer too. But I wanted to prove to you, even though that might be still easier, maybe complete the square still wins. Bye guys. What? Storage just laughing. Bye. Later, gators.
Dude, you sang you swept the room in your onesie.
If it wasn't report card grades, you would have already had it, but
Okay. Thank
messed
you.
me up.